our next guest is going to be Russell Butterfield, and a researcher, neuromuscular specialist, University of Utah. That's what I have here. And he's about that article. I think that's pretty amazing. Let's just make sure I have a message, make sure everybody's good to go. Before we officially welcome though Russell, I want to take a quick note that we're at now officially $41,000, folks. Let's keep it going. Raise the money. Text to give. Text FSHD to 243725. And now we welcome in Russell Butterfield. Hello, Russell. Should I address you as Russ or Russell?
Russ is pretty good.
Russ is good. Okay.
Unless I knew you in high school or you're mad at me.
I was about to say the same thing because people don't call me Timothy. And if they call me Timmy, we got real problems. So I wanted to be sure that I was on the same page with you. Well, thank you for joining us and spending some time with us here on this Giving Tuesday Radiothon and looking over some of this fascinating article that Allison Calder wrote for our advocate that we all read and are a part of. And she was starting to kind of talk about this story, this family lineage of FSHD, but that's why you're here. So I kind of want to give it to you and explain a little bit of the work you're doing.
Well, sure. The story actually goes back a long time, like 80 years.
Wow.
FSHD research here in Utah that all started with a geneticist named Fayette Stevens, who had trained at Cornell with some really prominent genetics people, but somehow landed here in Salt Lake City in the late 1920s, actually, when he first arrived here. And at the same time, one of the sort of founding physicians of all of medicine in Utah, a guy named Samuel Baldwin, had made contact with, he's an orthopedic surgeon, and come in contact with a number of people from this family with some type of muscular dystrophy. So he was familiar with them. And then by chance got to know the genetics, the people who were interested in genetics, and that really got the ball rolling. And so really through the late 1930s, early 1940s, they started collecting members of this family with what wasn't known to be FSHD at that time, but what was FSHD. And they examined individuals in the family, they collected family history and traced the origin of this family at least as far back as a Mormon pioneer ancestor who came to Utah in the 1840s. And he actually emigrated from England, from central England, Lancashire, around that time. And he had FSHD, so he came across the plains like other pioneers, but they had to set up a special rig for him because he couldn't walk very good, but made it here to Salt Lake City and had lots of progeny. And so by 1950, when the paper was published, they had identified 1,249 individuals in the descendancy from that one pioneer founder, and about 250 of them had FSHD or were thought to have it by historical records or whatever. And they had actually examined over 100 of them themselves. So we have the records from that original study that showed up on my office one day in a box. And we've been really interested in now reconnecting to that family, who's had several touch points along the way over the last 80 years, but that's how it all started.
So you said that this box of information just kind of, you said, landed your path?
Literally showed up on my desk one day and someone said, "This is yours." I can show you, actually. I don't know who's watching, but this is, we couldn't do this on the webinar today, but this is the box. Well, this is one of the binders in the box. It's filled with medical records, not medical records, but case report forms for individuals from that family. So it still sits here on the ground next to my desk because we're using it.
Yeah.
And it was immediately clear what it was. So this is kindred number 2, and it's got a little thing right on there, kindred number 2. And So that these guys had actually been collecting lots of different families with lots of different phenotypes. Kindred one is bone disease, and now I forgot which one it is, but several of the cancer genes were identified from families here in Utah from Fayette Stevens's work, and the breast cancer genes that people know about are family 107, and colon cancer was found here in Utah, all from genetic work that started back way in the 1940s, and in big Utah families that tend to stay here and have lots of progeny, but also know their family history, right? So if I ask these people, they know who their grandpa is, and they kind of know if he had this thing.
Right. And
so you can trace it.
Yes, you can trace it a lot easier. How about, I guess people might be listening and saying, okay, so if you know what's going on with this group, right, you're following or tracing the FSHD back then, what possible benefit or hope is there in all that information? You know, what can we learn to maybe help?
Yeah. So this gets our project that we're doing now. It's funded by one of the Wellstone Center grants from the NIH in collaboration with the UMass FSHD group. And what we've always thought that the family is a goldmine for research studies because they all share the same genetic mutation. And I think people understand that there's some control by the contraction size of that D4Z4 gene to control severity of the disease. But it doesn't control all the severity. And even back to that original paper in 1950, they really noticed that you might have variable severity between members of the same family, or from a severe parent to a milder child, or the other way around. And that's not controlled by the contraction. And in fact, in this family, and Kevin Flanagan showed this back in 2001 paper that he wrote, that sort of re-highlighted this family, that they all carry the exact same mutation. Even people who are very far apart genetically, right? They might be, you count back 13 different separate people between two individuals that are, living at that time. They carry the exact same mutation. And so we kind of control for the variable severity from the main FSHD gene, and we can test for variability of other genes that might involve one person being more mild and one person being more severe. So that's a study that really uniquely possible from this Utah Kindred, because it's a large family and you need a lot, because we're looking for probably more minor effects on severity than major ones. And you need a lot of people to detect them. But not only do we have that same family that all carry the same mutation, but we have a history with them that goes back 80 or more years. And in some cases, we might have an individual that was born, for just one actual example, an individual born in 1927 with a severe phenotype. And we know the course of his disease across his lifetime. And we know what its progression and its severity was like and its onset. We know that his sister, who had a much later onset in her 40s, and we know what her progression was like across her lifetime. But not only do we know that, we actually have DNA on those individuals. And that comes because these different touch points with the family over the years. So, 1940s, Tyler and Stevens were looking at genetics and interested in just describing what FSHD looked like in this family. But in the 1980s, Mark Leppert here at the University of Utah was thinking about mapping genes, and they knew all these families were here that had these different traits. And so he started collecting DNA. And those DNA still exist. So they've been kind of passed along from generation to generation of researchers here. And now they're sitting in our lab. So we have DNA. The oldest one we have is a person born in the late 1890s, sorry, for DNAs. But so now we have, a phenotype across a lifetime. We have a DNA sample. Some collected, as far back as the mid 1980s. And samples collected now when Dr. Flanagan was working with the family and later on. And now we have, more generations of that family as well. So new people to see and to involve with the research. And now we can think about a little bit different question of their severity and progression in a way that, where I have the historical record, I can see a scope of disease across a lifetime. but I don't have really precise data, right? I don't know that at age 42, their muscle strength score was like 5, right?
Right.
But with the current set of patients, people that are still living, and some of them even from that original pedigree that was published are still here, and we can examine them, collect more discrete phenotype information, and hopefully carry that forward into the coming years. So we now follow, in some systematic way. So
So
that's the benefit now.
and 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 it seems like that it possibly could hold the key of understanding why it affects people so differently, even from the same family, right?
Yeah. That's the idea, is that we can really drill into that question. Is one person's mild, one person's early onset, one person's later onset, one person's rapid, progression.
Yeah.
Really start to drill out what are the genetics that drive that, or maybe it's not genetics at all. Maybe it's some environmental factor or some other thing that we don't know about, but at least sets the stage that we can start understanding those things. And if they're a genetic factor, then we can start building treatments around those things too. And the idea is that if we have some biochemical pathway that makes a person a milder disease, we can now focus a treatment idea around that and try to give it to other people, right? Try to take advantage of that knowledge to build treatments.
And would it, in essence, then help to even forecast or predict if somebody has early onset of it, like, someone in their teens, and if you could figure out based on this information, is there anything shared to that person? Okay, you can expect to be this progression needing, these kind of aids. I mean, can it be a forecasting tool, do you think?
I potentially, and it all depends what we find as a result of the study initially. But and to maybe take Duchenne muscular dystrophy as an example, because our group with Bob Weiss here has done some studies on genetic modifiers for Duchenne, and they found a couple. They found a gene called LTBB4 and a gene called thrombosponin 1. You could start to build a predictive model, right? And you need a lot of information to build that model, but ultimately you could hopefully build a predictive model that would help forecast based on a person's FSHD mutation, but also other genes that would help say, okay, this is kind of the genetic makeup that every individual has and what our expectation is for progression.
Yeah, that's fascinating.
That's a ways down the road probably to be able to build that model, but this sets the stage for it.
Yeah. What did it feel like then when you started to wrap your head around what you were about to research into here? Those first, days or moments when this was put in your pile.
Well, I'll tell you that box landed on my desk at a time where I'd just gotten out of fellowship. And I could see like, wow, this is really cool.
Yeah.
What can we do with this?
Right.
And it took a while after that to kind of make the connections to the Wellstone Center. And we knew all along it was a treasure trove, but just didn't quite have the infrastructure to pull it off. And I think we've built that up over the last few years and really got it going now.
Yeah, absolutely.
But
I
it was like,
it is.
Yeah, it was funny that box dropped on my desk, and I was like, "Whoa, this is like a historical treasure!" Like,
Yeah.
and ultimately we found out it'd been checked out of an archive in 1995, probably by Dr. Flanagan, and never returned. And we went back to the archive a couple of months ago to see if anything else was left. It had all been destroyed in 2018.
Oh.
It all been just expired, right? It reached some 25-year archive limit and just been. So this box was actually saved from the shredders by never being turned back in.
It was meant to fall on your desk, man.
Yeah. No, they're gonna stay right here too. Or we'll put them in a museum.
How about those that are listening that want to know, are they tied into this? Are they related some way? How would they start to reach out to figure out to be a part of them?
Yeah, a couple simple ways. If you got the newsletter, there's a link or a QR code that you can just scan that'll take you to our website that can tell you that. And I gave a webinar a couple of weeks ago that had email addresses for our study. So, and you can get those back on the FSHD Society website. If those are all unavailable, if you go to our website, upin.genetics.utah.edu, and then click on the events tab, you'll find a link to something called the Roots Tech 2020. And
Okay.
just to tell you an interesting story, Roots Tech is a huge genealogy conference that happens here in Salt Lake City every year. And so if you click on that link to Roots Tech, it'll take you to some of the materials we put together for the conference, because we wanted to start identifying people who could potentially be related to the original FSHD founder here in Utah. And so we just put a booth in the conference, and there's 20,000 people there who care about genealogy. It's here in Salt Lake, so a lot of them are from here, have ties here.
Yeah.
And we actually found a fair number of people who originate from that original FSHD family. And there's one other big pedigree that's also segregating here in Utah that goes back to those old days. There's links if you go to our sort of page on our website about Roots Tech, about how to tell if you're a part of the family, and you'll see some pictures from the conference, and a couple other things, just some information we put there about how do you tell. But we can help you do that too. So even if you just email us, that's a good way. One of the highlights of that conference was actually we met a gentleman stopped by the booth who was said, I think my mother knows something about this. And so he brought her out the next day, and her name's Beverly Dow. She's 96 years old. And it turns out she's a part of the original family, but in an unaffected branch. But more cool is that she's the artist who drew that original pedigree with 1,200 little squares and circles on it, all
Wow.
beautifully marked together. So we got to talk to her about the old days when she was working with Tyler and Stevens, and how did they pull that off? How did she actually draw that and make it look so cool? So that was really the highlight of that trip for us, was to talk to.
Phenomenal. Well, thank you, Dr. Russ Butterfield, for joining us and sharing that information yet again. Yes, looks like Anna Gilmore of the FSHD Society posted it on the posted a link of the webinar there.
Oh, great.
For us all.
Yeah, because
we have that. That's good stuff, man. That's so fascinating. That's so fascinating to me, just the history of it and what you are walking into. You're almost like a detective.
It's been kind of a fun project to just search out, find something new. It's not what I thought I'd be, like in the lab with a pipette.
Yeah,
it's a different kind of detective work.
Different kind, absolutely.
But kind of a fun project, and to pull it all together, right? And really, what we're trying to do now is just pull back all these resources have been collected at different times by different people and turn that into a really core resource.
Yeah. That's awesome. So those want to learn more, Dr. Butterfield has got the links out there for us, all through fshtsociety.org. Thank you, Doctor, for joining us today on this Radiothon event. We appreciate your time.
Yeah, great to talk to you, and it's been a fun time.
Thank you. Yeah.